Guys, this is Shashank, and now I'm going to solve the first question in the maths in some paper.
So the first question states, in a room containing 20,000 cubic feet of air, 600 cubic feet of fresh air flows in per minute, and the mixture is exhausted at a rate of 600 cubic feet per minute. What is the amount of fresh air, y of t, at any time if y of 0 equals 0? After what time will 90% of air be fresh? Okay, so we are given that the volume of the container is volume of the room is 20,000 cubic feet, and the rate of inflow of air is 600 cubic feet per minute. So the rate of outflow, R out, it's a we need to use unitary method to calculate R out. So the amount of fresh air in 20,000 cubic feet is y of t. So the amount of fresh air in 600 cubic feet equals y of t by 20,000, that is for 1 cubic feet of air, but we need to find out for 600, so times 600. So this is R out, y of t times 600 by 20,000. So now y of t is the amount of fresh air at time t. So the change in the amount of fresh air at any given time t should be y dash of t. So y dash of t is change in amount of fresh air at time t. Also, logically speaking, change in amount of fresh air should be rate of inflow minus the rate of outflow, that is R in minus R out, and that is 600 minus y of t times 600 by 20,000. Okay, now this is pretty simple. Let's simplify this. We get y dash of t plus y of t times 3 by 100 equals 600. So to convert this into a linear differential equation, all we need to do is multiply the entire equation by 100 by 3. So that gives us y of t plus 100 100 by 3 y dash of t. So 100 by 3 is 60,000 by 3, that is 20,000. This is a linear differential equation, but I'm going to solve it in the normal method. So it's basically, we can write this as y plus 100 by 3 dy by dx dt, sorry, that's a mistake, dy by dt equals 20,000. So now all you need to do is some minor rearrangements, and then we need to integrate. So y minus 20,000 is equal to minus 100 by 3 dy by dt. Now I'm going to rearrange this. It's pretty simple. I'll take y minus 20,000 to the denominator and minus 100 by 3 dt to the left hand side, and then I get minus 3 by 100 dt uh, equals 1 by y minus 20,000 dy. Now I'm going to integrate on both sides by integration, definite integration on both sides. So we'll get minus integral of 3 by 100 dt equals integral of dy by y minus 20,000 . Let me just arrange this. Yeah, okay, cool. So that's pretty straightforward. The left hand side we get minus 3t by 100 equals natural log of mod of y minus 20,000. It's normal integration. And now for the constant we can take plus c, but let's take ln of k because that makes our calculation much easier. That's basically the constant of integration. So that turns out to be 3t by 100, and following the laws of logs we get k times y minus 20,000. So now natural log is always to the base e, so I'm gonna bring the e to the left hand side. That gives us e power minus 3t by 100 equals k y minus 20,000. So that's I'm just gonna swap the LHS and the RHS. Y minus 20,000 equals e power minus 3t by 100 by k. 1 by k I'm assuming as a for ease of calculations, because it's better to have something in the numerator than in the denominator. E power minus 3t by 100. So that's our first equation. Let's assume it as our first equation. So now we know that y of 0 is equal to 0. That means the fresh air at time t in the room, fresh air at time t equal to 0 in the room is 0. Therefore at t equal to 0, since y is 0, so minus 0 minus 20,000 equals a times e power minus 3 times 0, so that's 0. E power 0 is 1, so that, and we get a as minus 20,000. Now substitute this in equation 1. That gives us the most important equation of the problem, probably. Y minus 20,000, y minus 20,000 equals minus 20,000 times e power minus 3t by 100. Now after simplification we get y of t equals 20,000 times 1 minus e power minus 3t by 100. I just took this part to the right hand side and I got this equation. Let's consider this as equation 2, even though we don't really have much use for this notation, but let's consider it as equation 2. So this is the solution of the problem. Now the second part of the question asks us at what time will 90% of the room be filled with fresh air. So let's find out what is the 90% of the volume V. 90% of volume V is 0.9 times 20,000. That is basically 18,000 cubic feet. Now we have y of t as 18,000 cubic feet. So 18,000 cubic feet equals 20,000. Sorry, not cubic feet, it's just 18,000. 20,000. So 20,000 times 1 minus e power minus 3t by 100. When I bring this to the left hand side, I get it as 0.9 equals minus e power minus 3t by 100. So I swap the terms again and I get e power minus 3t by 100 equals 0.1. I took 0.9 to this side and 1 minus 0.9 is 0.1, and this became positive when it came to the right hand side of the equation. So we initially had e power 3t by 100 minus 3t by 100, sorry, equals 1 by 10, right? 0.1. So that is 1 by e power 3t by 100 equals 1 by 10. So e power 3t by 100 equals 10. And now I'm going to apply natural log on both sides. I get natural log of 3t by sorry. When I apply natural log on both sides, this becomes 3t by 100. Natural log of 10. So natural log of 10 is 2.302. So 3t by 100 equals 2.302. So t equals 230.2 by 3. That is approximately 76.7574 minutes approximately. That is approximately 77 minutes. Therefore it takes 76.75 minutes for 90% of the room to fill with fresh air. So that's problem 1. Thank you.